We're in General Physics 1, and we're doing Chapter 7 problems. And problem number 3, I've got a 7150 kilogram railroad car, and it's traveling along. The frictionless track velocity is 15 meters per second. And a load is put into the car. What's the new speed? So V1 mass 1 has to equal velocity 2 mass 2. And so 7150 15 meters per second has to equal some 7150 kilograms plus the load that I just put on, 3350 kilograms, times some velocity 2. So my velocity 2 is 7150 kilograms, 15 meters per second, divided by those guys added together, 0, 0, 1 to carry, 5, 1 to carry, 10. And then we just put in our calculator real quick. And we find the new speed to be 10.2 meters per second, and then we ask ourselves how many significant digits, and we clearly have 3, so that's fine. Next problem number 5. And, calculate the force exerted on a rocket when the propelling gases are expelled. So I've got 1,300 kilograms per second with a speed of 4.5 times 10 to the 4th meters per second. And force is mass times acceleration, which is in newtons, which is in kilograms meters per second squared. So clearly the force is going to be 1300 kilograms per second times 4.5 times 10 to the 4th meters per second, and my units come out to be in newtons. 1,300 times 4.5 double E4. So I've got 5.85, and I may not have as many significant digits, 10 to the 7th newtons. And then I look and see, and I only have 2 significant digits in the problem. So for my final answer, I'd say I go with 5.8, 10 to the 7th newtons. And problem number 16. Am I going fast enough?
Yeah.
A golf ball, mass 0.045 kilograms, is hit off the tee 38 meters per second. That's not very much. The golf ball is in contact for, so my delta t is going to be 3.4 times 10 to the minus 3rd seconds. Find the impulse imparted to the golf ball. So we move back a couple pages and we see that impulse is force times change in time. And I'm looking on page 189. So I need force is mass times acceleration. Change in time. So we'll move back to impulse. Force change in time, but it's really change in momentum. So it's change in momentum. So my change in momentum, I was at 0, and now I'm at 0.045 times 38 meters per second. And I end up with 0.048 times 38, 1.71, 1.7 kilograms meters per second. That would be my impulse. Okay, all right, good enough. 1636. And the internal explosion breaks an object into two pieces. One of them, okay, so I got two pieces. I got this piece over here, which is of mass 1, and then I got this other piece over here that's 1.5 mass 1. And bigger than the other. So I've got 5500 joules that are used, is released in the explosion. How much kinetic energy does each piece have? Okay, so kinetic energy is 1/2 mass velocity squared. Okay, and momentum has to be conserved. So velocity 1, mass 1 has to be velocity 2, 1.5 mass 1. So velocity 1 has to be 1.5 velocity 2. That has to be the case. So the kinetic energy, so the 5500 joules has to be the kinetic energy of the first guy, 1/2 mass 1 velocity 1 squared, plus the kinetic energy of the second guy, 1/2 1.5 mass 1 times velocity 2 squared, which would be velocity 1 divided by 1.5, the quantity squared. Alright, that being the case, I have okay, what am I going to do with that? Alright, so I'm going to change that to 1/2 mass 1 velocity 1 squared plus, this is, so I got a 1/2, I got a 3/2, and then I got divided by 1/3/2 velocity 1 squared, and this guy is squared. Okay, so one of them goes away, he turns over, so I'm going to have 1/2 mass 1 velocity 1 squared is equal to 1/3 mass 1 velocity 1 squared. Okay, so I have, that's a plus sign. So 1/2 and 1/3, and those guys there are just whole numbers. So 1/2 plus 1/3 gives me 4, 5, 5, 6, 5, 6 is my total. So 5, 6 mass 1 mass velocity 1 squared is going to be the 5,500 joules. Well, actually, so mass 1 times mass velocity 1 squared has to be 6,600 joules. Alright, so we'll come back here, and half of that is 33, come back to here. Half of that is going to be 3,300 joules, and the other one's going to be 2,200. A third of it's going to be 2,200 joules. So that's my answer. So mass 1 has 3300 joules of kinetic energy, and mass has 2200 joules of kinetic energy. Okay, so that was 36. Going on to number 53. 53. So we have a pallet with identical cases. There's 10 of them, and each of the cubes is length L. Got that. Find the center of gravity in the horizontal plane so that the crane operator can pick up without tipping. Okay, so we want the center of gravity in the horizontal plane. Okay, so that means we need the center of gravity in the x direction and the center of gravity in the y direction. So the center of gravity is the sum of the masses times the distance divided by the sum of the masses. Alright, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 masses. In the x direction, I've got 1, 2, 3, 4, 5 of them. 5 of them at L over 2. And then I got 3 of them at L over 5L. 5L over 2? 3L over 2. And then I got 2 of them at 5L over 2. And that guy there's a 3. And for in the y direction, I want the center of masses times y divided by the sum of the masses, and that's going to be over 10 again, because I have 10. And then I'm going to have 1 times L over 2 plus 2, 3L over 2 plus 7 at 5L over 2. So the center of mass in the x direction, 5 halves, 9 halves, 10 halves. Alright, so 10, 15, and 9 is 24 halves. So that's be 12L over 10. The center of mass in the y direction, I got 35, 36, and 6 more. 42L over 2 divided by 10. So for my final answer, the center of mass is going to be at 1.2L and 2.1L. And that's in the x direction and the y direction. I'm now looking at number 71. 71. I have bumper cars and mass of car A. Okay, so I have mass of car A, mass of car B. I have velocities. I want to A, calculate their velocities after the collision, and I want to calculate the change of momentum of each. And it says blah, blah, owing to differences in passenger masses, car moving and calculate the blah, blah, blah. Alright, well, mass 1, velocity 1 plus mass 2, velocity 2 has to equal mass 1, v1 prime plus mass 2, v2 prime, where that's after the collision. So that being the case, I got 435 times 4.5 plus 495 times 3.7 has to equal 435 times, I don't know, velocity A prime plus 495 495 velocity v prime. And then, so that's my momentum that has to be conserved. And then my kinetic energy, 1/2 mass velocity squared plus 1/2 mass velocity squared has to equal 1/2 mass velocity squared plus 1/2 mass velocity squared. And now I have two equations, two unknowns. So I'll go and take the first equation and rewrite it as 4.5 times 435 plus 3.7 times 495. So I've got 3789 is equal to 435 VA, and I'm going to drop the prime just because I don't really need a prime, so but really the V and B free are both prime. And then I'm going to do the same thing with the guy up above, except before I do it, I'm going to say, well, gee, I don't have to, I have a half everywhere, so I don't have to worry about it. I just take it out. Okay, so I got 435 times 4.5 squared plus 495 times 3.7 squared. So I got 15585 is equal to 435 VA squared plus 495 VB squared. Okay, so now I have two equations, two unknowns. So I'm going to take the top guy and say that VA is equal to 3789 minus 495 VB. And then I'm going to put that back into the first equation. So now I got 15585 is equal to 435 times 3789 minus 495 VB plus 495 VB squared. Alright, so I'm going to rewrite that guy as 495 VB squared minus 435 times 495. And I'm going to have 15325 VB, and then plus, and when I get done it's going to be equal to 0. So 435 times 3789 equals, subtract from that 1585. Okay, I got the right number, and I'm going to have 1.61958 times 10 to the 6th. All right, now I'm just going to go to my differential, my polynomial solver, and say VB is equal to something. So second function polynomial solver, my A is 495, my B is minus 2152325, and my C is 1.619588866, and I'm telling them it's going to solve it. So VB is 7.65, or it is, that's totally impossible. Or it's 427. So I put something in wrong. What did I put in wrong? 495 minus 215325 and 10 to the 6th. What am I doing wrong? Solve. Okay, so I did something wrong. And so now we're going to go back up and see if we can figure out what we did wrong. I didn't square that right there. So I didn't square that. That's what I did wrong. Alright, well that is a horse of a different color, isn't it? So I have to square that guy. Alright. 15585 is equal to 435 times 3789 squared minus 2 times 3789 times 495 VB plus 495 VB, the whole thing squared, plus 495 VB squared. Alright, well, that's pain in the you-know-where. Alright, so I've got 495 plus 495 squared times 435. Okay, so I got 1.06 times 10 to the 8th VB squared. This looks like a big minus number. Okay, minus 435 times 2 times 3789 times 495, 1.63 times 10 to the 9th VB plus 3989 squared times 435, and subtract from that number 15585, 6.146 times 10 to the 9th is equal to 0. Okay, now I go into my equation solver, and I find that my A, 1.06 double E8, my B, minus 1.63 double E9, my C, 1.146 double E9, solve it, and I get X1 is 6.62, and X2 is 8.75, and I know that that's wrong too. Alright, so I've gone and gone through the problem twice and got the wrong answer both times, so
Should we write shit on your paper and then?
no, it's just a matter of it. There's too much there to know where the mistake is. There's going to be two answers. How do I know those answers are wrong? That's the issue. How do I know those answers are wrong?
Should they be negative?
No. I know they're wrong because there's going to be two answers, and this is for the B guy. One of the answers is going to be bigger than 3.7 because the A guy hit him, and he's going to be going faster than 3.7. The other answer is 3.7 because the A guy missed him. So the two answers come from hitting him or missing him. And but it can't. They both can't be bigger than what it is.
Mm-hmm.
So that's how come I know it's wrong. Okay, should you want me to do it again?
No.
Okay, but that's the way you have to solve the problem. And somewhere I managed to drop a minus sign or something. But that's how I know it's wrong.
Okay.
Okay, so